Welcome to lesson 4.6. The title of this lesson is Stretches and Shrink of an Absolute Value Function. By definition, absolute value is the distance between a number and 0 on a number line. The absolute value is indicated by two vertical lines with probably a number or an expression that is inside that line. Again, those two vertical lines indicate the absolute value function. The objective for this lesson is for you to be able to shrink the graph of an absolute value functions or stretches it out and makes it wider. All right, so let me give you a little bit more background information on absolute value. So again, the definition is absolute value is the distance between a number and 0 on a number line. So I have two quick examples below. The absolute value of negative 2.3. If I look at the number line, negative 2.3 is probably approximately right here. So the distance between this point of negative 2.3 and 0, that distance is a positive 2.3. Okay. Now, what about the absolute value of 5.2? Imagine that 5.2 is located right here on the number line. Well, the distance between 0 and 5.2 is a positive 5.2. I almost want to think of it as, because it is the distance of something, it's never really going to be a negative, unless you're looking at the negative of the absolute value of 5.2. Well, the absolute value of 5.2 is still 5.2. And that negative sign that's outside, that is the same thing as multiplying it by a negative 1. So you will get a negative 5.2. So if the negative sign is inside the absolute value bars, then it will come out positive. If the negative sign is outside, it will remain negative. So what does the graph, what does the function, absolute value function looks like? So imagine that I have a function of y equals to the absolute value of x. I'm just going to pick a few value for x. Let's say negative 3, negative 2, negative 1, 0, 1, 2, and 3. Hopefully with these few values, we will be able to see a pattern and create a graph. So when x is equal to 3, you're looking at the absolute value of negative 3, meaning that the distance between 0 and negative 3, which is then a positive 3. When x is equal to 2, you're looking at the absolute value of negative 2, which means the distance between 0 and negative 2, which is a positive 2. For the absolute value of negative 1, again, you're looking at the distance between negative 1 and 0, and that will be a positive 1. Well, when it's 0, the absolute value of 0 is just going to be 0 because you're right at 0 already. The distance between 1 and 0 is going to be a positive 1. The distance between 2 and 0 is going to be a positive 2. And the distance between 3 and 0 is going to be a positive 3. Now I'm noticing something. For the domain of my graph, I notice that x can be any number, okay? X equals all values. So it could be a negative values, it could be a positive value. The range, however, those are the y values. I notice that the range are all greater than 0 or 0. It could be 0 as well. Okay. So the domain are all values between negative infinity to positive infinity, and the range are all positive values. So let me plot these points. When x equals to negative 3, y is positive 3. When x is equal to negative 2, y is 2. Negative 1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. If I connect the dots, you will see that our absolute value function will look something like this. All right? Now, if you are going to graph this on your calculator, okay, you would then press the y equal button, and then you would press second button and the 0 button at the bottom. And you will find that the first thing that you see after you press second 0 is ABS, which stands for the absolute value. Okay, so let me move that out of the way. So first press the y equal button, and then press the second button, and the 0 button, and then ABS stands for absolute value. Okay. So let me do a quick mathematical question here. How do you solve an absolute value equation? What absolute value will give you a positive 8? Which, if you think on the number line, all right, so let me just quickly draw a number line. So we have 0, and the distance between 0 and 8. Okay. Now you'll notice that I have actually two solutions, because the distance between 0 and 8 is actually a positive 8 and a negative 8. So in this particular case, x will equal to negative 8, because the absolute value of negative 8 will be a positive 8, and also positive 8, because the absolute value of 8 is 8. Right. Now let me move that back to the graph for a second. If I'm looking for the absolute value of x is equal to 8, so the green line that you see there, that's my absolute value function. The 8, imagine that there is a horizontal line at 8, because the slope is 0 and the y-intercept is 8. You'll notice that I have two intersection points, and the two intersection points are at 8 and negative 8. Okay. So again, keep in mind when you're solving for the absolute value, you will have two solutions. Okay. Now, translating the absolute value is exactly the same as if you were translating a parabola or a line. If I wanted to move the graph left and right, I would replace x with an x minus h, h being however many units you want to move left and right. All right. And if I want to move this absolute value function up and down, that would be the same thing as adding the k value at the end of my function. So let me write that down. So y equals the absolute value of x minus h. Again, keeping in mind that minus actually implies that it is moving to the right, and plus implies that it is moving to the left. And then the plus k implies that we are moving this absolute value function up, and minus k would mean that we're moving it down. Right? Now let's solve for a translated absolute value function. So here's my second example here. This absolute value function of x minus 3 plus 2 equals to 7. Graphically speaking, this x minus 3 means that I am moving this function to the right 3, and I'm moving it up 2 because of this 2 at the end here. Okay. So graphically speaking, I am going to take my absolute value function, which is this v-shaped function, and I'm going to move it right 3 units and then up 2 units. So that's what my translated absolute value function will look like. Now for that 7, imagine that there is a horizontal line at 7, right there. So you'll notice that I have 2 intersection points, and it looks like the 2 intersection points is located at x equals to -2 and +8. All right. So let me show you how I can get -2 and 8 without having to graph it. Okay. So the absolute value, I treat it like it's a parentheses. All right. So if I'm going to solve for x, remember I'm using PEMDAS backward. So if there's anything added to or subtracted from, I want to get rid of it first. So I'm going to subtract 2 from both sides. When I subtract 2 from both sides, I have the absolute value of x minus 3 is equal to a +5. All right, now, to remove those absolute value sign, I have to think about the distance between 0 and 5. Now, the distance between 0 and 5, I have 2 solutions. It is at 5, a +5, but the distance between 0 and 5 also goes on the negative side, and that's the -5. Right? So that's when I'm going to get my 2 solutions. And you'll notice that if I add 3 to both of my solutions of 5 and -5, I'm going to get x is equal to 8 and -2. Right? So you could solve for x without having to graph every single time.